Earthing and grounding products depend on the supposition that the body needs to be grounded to the earth. And the initial studies were done with copper rods in the ground and a wire going around a toe. And so you'd have a reasonable basis to assume some electrical connectivity. Now, I was unfamiliar with rubber, which is normally a resistant. I put rubber tape around electrical connections in order to avoid getting shocked. So the idea of a rubber mat just connecting, with no copper into a wire seemed odd to me. And because the tests are not being presented in many of these products, the first thing to do is to do a test, which you can see with light here. So this is a 9-volt battery, brand new, and when I connect a 9-volt battery to this light, you get a pretty good brightness. It would be nice if the sellers would do an exact measurement of luminosity, but that's a pretty good brightness. Now, if I instead connect this snap key here to one side of the battery and put the light into the other side, you see that at roughly 1 centimeter distance from the snap, the light is reduced by more than 50%. What this means is that this connects or this conducts with at least 50% resistance. So you see the bulb here, and then you see the bulb directly. All I'm doing is bypassing 1 centimeter of fabric. Now, if I connect the snap and put that on one end, to the battery, what this is doing is it's testing the impact of the wire, because it's a thin wire. Grounding wires out of a house can be up to ½ an inch thick. This wire is, maybe 2 millimeters thick. So if I connect the snap and the wire and go to the same point, you can barely see the light turn on. So again, a 50% reduction as a result of using a long, thin wire. So you barely see the light turn on. We take the wire out, we connect the battery directly to the snap, and we see double or triple the amount of luminosity. We connect directly to the battery, and we see again double or triple the luminosity. And there is no 9-volt battery in the earth to facilitate overcoming this resistance. What we're seeing is that there's resistance to grounding and flow in the wire, and there's resistance in the fabric. And so the next test, which I haven't done yet, would be, can I touch my foot to the fabric, connect the prong to the one side of the battery, and then touch another side of the battery to my foot and get any electrical charge. Now I cannot, okay, I can slightly see, you won't be able to see it, but there is roughly a 2% connection. So if you barely look at the first few buttons of LED with this, you'll see that with a full-on frontal, meaning a bare foot directly down pressing hard, and the wire poked in, you'll see, the smallest amount of shift, yet. So the trouble is that if this is a sleeping thing, it would be more like a heel. So let's try, your heel connecting and see if there's a shift. There isn't. That's good. However, some people have asked and been told that wearing socks is maybe not ideal, but just fine. These are wet cotton socks because I sweat. These are 100% cotton. And so if anyone's socks are going to work with this, they're going to be these socks. And so the question is, can we get any juice whatsoever with a full-on connection here? Now, there's zero with the sock, but let's poke through and get skin like we did before. Okay. There is some penetration through the sock and sock moisture. So the way I would say it is, if this is 100 in terms of connectivity, then this is somewhere between 3 and 5%. So plugging this in with a bigger wire might lead to more of a, again, going back to here, where you see much brighter so you can see that. You can't really see what's going on with this wire. So I can see this. I think you can see it as well, yeah. But we take that with the wire and go to this, and you can see that this cheap wire is costing 2/3 of the impact or more versus if it was all thick like this bit here. So so there's the results, and the conclusion, in my opinion, would be go with a product that has a thicker wire because a very thin, long wire reduces the impact of the mat by 2/3. Socks reduce the impact, it seems like, roughly 50%, and being heel or full on doesn't seem to make too much of a difference. And there's not too much of a difference going away from the mat, from one portion to another, because we can see that it's fairly bright with 1 centimeter, distance. So if we're testing, I don't see the difference. So in other words, this mat seems more conductive than the wire, which is counterintuitive. Because if we bring this mat and ask the current to travel all the way diagonally through here, come into view, we're still getting more brightness here than we are going through this wire. So this wire is the weak point in this product.